Hey Liam, I saw your post on Hacker News and what you wrote is awesome. I thought it might be helpful to give you a little code review like you might get if you were working in industry, and hopefully you might learn a thing or two along the way. I'll admit right off the bat that everything might not make sense immediately, but hopefully there will be a few breadcrumbs that will pique your interest that you'll want to follow up on. So we're just looking at my terminal, and on the left-hand side is your code, and on the right-hand side, I'll just be running your program, and we'll just be hopping back and forth, making sure things continue to work as we make changes. So, stopping down to the bottom, the first area I want to focus on is kind of this animate area. So, I noticed that you have this variable called map, which is a good name, but it's a term that's used a lot in programming languages, either for data structures or for a common function that takes an array and produces a new array by mapping a function over it. And so maybe we should call this something else, just because that could be a little confusing. And really what this variable does is it holds the state of the world. And so state or world would probably be good names for this. For now, let's just rename it to state. Map to state globally. And so now map is called state. Code still works. Great. The next thing that I noticed is you have a few lines here that are dedicated to just printing out the state. So let's move that into a function just to make it a little more descriptive. And it'll just take a state, we'll convert the state, and then we'll just print it out. But we can do this a little bit differently, actually using that map function that I just mentioned. Let's call it row this time, and we'll take the state and we'll map over it. And for each item in the state, if the item is equal to 1, we'll return this character. And if it's not, we'll just return an empty space. And this operator, this question mark and semicolon, this is called the ternary operator, and it's basically like an inline if statement. The neat thing is, at this point, row is now an array of characters, and we can convert that array to a string just using join. So now we have this print method that's a little more descriptive about what we're doing, and we can just print the state. The problem is, well, technically this would work, but state is a global variable, and generally you want to avoid relying on global state. So we'll explicitly pass it in to animate. We'll pass it in here, and we'll save. And this is going to cause an error, but it'll maybe highlight something. You'll notice that it printed out one row, and then it says cannot read property map of undefined. And that is because when we recurse here, we also need to pass in state. And while we're here, because we're only calling a single function, we can just tighten this up a little bit, like that. And now this should all work. The other nice thing about passing in state like this is now we can make this a constant. So we just have a few more guarantees about, who's able to change that variable. And now map, or animate rather, is a little simpler and a little clearer about what's going on. We print the state, we evolve the state, and then we schedule the next frame. So let's just leave this alone for now, and we'll jump up to evolve. Well, actually, before we get to evolve, there is one more thing I want to change here. Process, every single time you animate, you parse this variable, and this variable is never going to change. So we can also move this, kind of hoist it up to the global state, and call it rule. And then we can also pass that into animate. The really neat thing here is now animate, the arguments to animate kind of encompass everything that we didn't know about running this program. It's the current state of the world, and then what kind of mutations we'll make to that world. And let's just clean this up a little bit. Cool. So now we're in evolve, and related to rules, I noticed every single time you call evolve, you parse the rules into a rule set. And again, that rule set's never going to change. So let's just parse that once and then pass it into evolve. And we can do that. Let's make another function. Generally making lots of functions, like lots of small functions that describe what you're doing is useful. It kind of gives you a vocabulary to use in your code so that you can be a little more descriptive about what you're doing. And so what are we doing? We're parsing rules. So we'll take a rule, that code from evolve, we'll just paste it in. We'll convert, and we won't really change this code right now. We'll probably come back to it later, but it's basically the code as you wrote it, except now we'll only run it once. And we want to parse it before we pass it into animate. This is a little sloppy, but I mean, I guess we could do something like this. I'm just generally a fan of lots of descriptive variables and lots of descriptive functions. So, but yeah, we'll just leave it. Maybe we'll revisit naming later, but that's probably good enough for now. The nice thing is, now we parse the rules once, we pass them into animate, animate passes them into evolve, and just about everything should work, except we might have a reference to rule set in here that we need to update. And then if we come back to your code, great, still works. All right, so while we're in here, all this code is doing is duplicating or copying the array. Oh, speaking of which, we should probably rename this to state, just to be consistent. And there's a shortcut we can do just like that, that will copy it. We'll leave these alone for now. And this, this guard that you have here is good, but I'm going to invert it a little bit. I'm going to say if it's equal to 0 or equal to the array, the last element of the array, we'll just return. And that's kind of just a style preference. I like to early out of functions as soon as I can. Those are called, in some languages, those are called guards. But it's also going to help us out a little bit later, I think. So moving on to lines 21 and 22, you can actually just simplify this to this. I see you're using the string to coerce this into a string. But then, so you're basically making a binary string, and then you're trying every single possible binary string from, what is it, 0 to 7. And we can actually invert this logic a little bit, where instead of counting through all the numbers and converting them to binary, we can just convert this to binary, and then we just know that we can push that rule. We don't need to do all those comparisons anymore. Let's see if the code still works. And it does. Great. Let's see. So the other neat thing about this is we can use map again. And when we use functions like map, that's usually referred to as a functional style. Again, it's just preference, but it's pretty common in JavaScript. So we'll do this, and then instead of pushing to new array, we just return the rule that we want. And let's see. So just while we're in evolve, let's see if we can get rid of this unshift and push. It just seems kind of asymmetric and a little weird. It's also the reason why we need this guard right here. And kind of a more JavaScript-y way of handling that would be I don't know if this is any better, but this is a pretty common pattern where you'll you'll try to get a value, and if it's false or undefined or null, you'll default it to some other value. And you can do that with or. And so we can do that here. And in theory, everything should keep working. Great. It does. And then the neat thing about that is it allows us to not even create the old array. We can just map over the state now because we're not mutating the old array in any way. And this should still work. Oh, we don't have old array anymore, but that's fine because we can just reference state. And the code still works. And then, we're creating this variable and then just returning it right away. And we can just return the results of map. This is, again, just personal style. But I think it reads well in this scenario. I guess the last thing that I would do here is, instead of converting a bunch of numbers to a string and then converting it back to an integer, we can just use some multiplication and do the conversion directly. And this just kind of involves knowing a little bit about how binary numbers work. So in this third spot, what do? We multiply by 4. In the second spot, we multiply by 2. And in this third spot, we multiply by 1. So we don't have to do anything. If you want it to be, say, symmetric, you could do that. I don't know if that reads any better. Cool. Our code still works. And now string is not a good variable name at all. Let's just call it the rule. And now we can just return the rule that we've computed. I have mixed feelings about cramming all this logic onto one line, but we'll leave it alone for now. Let's see. So the zero fill function, this felt a little weird. And okay, cool. So you're only using it in one spot now. Let's just get rid of it. And so let's see what we're doing here. We are taking a rule, converting it to binary, converting each bit to a character, reversing them, and then setting the corresponding bit in the corresponding index in rule set. I think we can definitely do a little bit better. So let's just move all the parsing logic into this function. So now we can call this, say, input. We'll call this rules, and the rules are computed by parsing the input. And over here, we'll take an input. We will, we'll just parse it. And base 10. And then one kind of short way, now that we don't have zero fill, we'll call, instead of rule set, we'll call it base. Let's just make an array of 8 items, or at least, so this will create an array that has its length set to 8, but it's still kind of empty. So we'll fill it with zeros. And then for each index in, okay. So we don't really care about the items in base, but we do care about the index. And this is going to be a little voodoo if you're not familiar with Boolean arithmetic, but you can take any number. In fact, let's just call this, we'll call this our rule, and in this case it's an integer. So you can take a number and you can AND it with a power of 2. Oh, I keep doing it. And it will tell you, and so this function, if you have like, this is the same as 2 to the third, which is the same as 8. And if you're familiar with binary numbers, this will be 2 to the 0th, 2 to the first, 2 to the second, and so forth. So by doing this, we're basically just moving a 1 along the bits. And then we're just asking, by ANDing it with the number, we can just ask, is this bit set? And we can do that by, I mean, there's a couple ways we can check this, but let's just be really explicit. And we'll say if it's 0, that means it's not set. Otherwise, it is set. And I think that's it. I think that basically does everything you were doing before. So we'll just return that. Let's make sure our code still works. It does not. Where are we using parsed? Oh, great. And just for consistent naming, let's call this rules, and we already call it rules there. Great. Cool. Code still seems to work. And let's see, is there anything else? I guess this video is getting a little long, so I'll kind of cut it off there, but that's the gist of how I was thinking about this. Many other engineers in industry might think about it a different way. The style that we used here is pretty functional, but you'll also often come across an alternate style called imperative, and in a lot of modern languages, you'll see both styles mixed a lot. But yeah, so it looks like we cut the code in about half. We added lots of little helper functions, and at the same time we made it a little more descriptive about what's happening. So I'll just leave it at that for now. Hopefully this was useful, and if you have any questions, don't hesitate to reach out. Thanks.